All right, students. So now we are going to do prime factorization. So as we all know, prime numbers are numbers that have only two factors, number one and itself. Okay, so for example, number 5. The only way that you can express number 5 is 1 times 5. So the factors are 1 and 5, right? But if you look at something like number 10 can be 1 times 5, 1 times 10, 2 times 5. It can have 4 factors, right? Number 1, number 2, number 5, and number 10. So prime numbers cannot be divided by any number besides the number 1 and itself. We also know that number 2 is the smallest prime number, and it is the only prime number that is even. So today what we are trying to focus on is prime factorization. That means we're going to take numbers, right, and break them down into prime numbers. So let's take a look at the worksheet today. Okay, that was just a test. Let me get rid of this. So students, we're doing prime factorization today. And we can see that prime factorization is taking a bigger number and splitting it down into its prime factors. So we use branching to do it. Now we'll do some examples later on. We are also going to touch on square numbers. So what is a square number? Students, whenever you take a look, whenever you try to find the area of a square, right, they will tell you to take the side multiplied by the side. And since the sides of a square is always of the same length, okay, all the sides are of the same length, for example, 5 and 5. So you take 5 times 5, you get 25. And guess what? 25 is a square number. So the same number multiplied by itself will give you a square number. So if the sides of a square is, let's say, 3, then you'll take 3 times 3, and you'll get 9. So you can say that 9 is a square number, okay? So a square number is basically taking the same number multiplying by itself. So if I were to take 10 times 10, I'll get 100. So 100 is a square number. There's just some other examples, okay? So you see all these examples here, these are all square numbers. Yeah? 1 times 1, 2 times 2, 3 times 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, right? Okay, so this will become important later on when we are going to do some word problems. Okay, so for now, we will practice our prime factorization first. So let's take a look at the prime factorization. I'll show you the first example, 100. We are going to branch it out. We're going to say 10 times 10 equals to 100, right? And we also know that 10 equals to 2 times 5. 10 equals to 2 times 5. So we circle all the prime numbers. And we can then write down 100 equals to 2 times 2 times 5 times 5. I'm always going to arrange the numbers from small to big so that I will not make any careless mistakes, especially when I do word problems. Sometimes when you do word problems, they want you to count. How many number 2s are there? How many number 5s are there? That's why I always make it a point to arrange the numbers from small to big. Not only will I not miss out the number, but if I want to count the number, I can easily count. There are 2 2s. There are 2 5s. Okay, students? And guess what? You want to talk about square numbers? Let's take a look. Can you see that number 100 is a square number? Why? Because it has one pair of 2s and one pair of 5s. Okay, if you were to rearrange it, do you realize that this group is exactly the same as this group? You are taking, let's say, group A and group B, okay? When you take 2 times 5, you get 10. When you take 2 times 5, you get 10. It's as if you're taking 10 times 10. Do you realize that the numbers in group A is exactly the same as the numbers in group B? So when you take two groups of the same numbers and you multiply them together, you will get a square number. Let's do another example. For example, if I take a group of numbers, multiply by another group of numbers, okay? So let's say I have 2 times 3 times 5 times 2 times 3 times 5. So what do I get? 2 times 3 is 6. 6 times 5 is 30. 30 times 30, I will get 900. 900 is a square number, students. Okay? So if you come across a question, okay, that telling you that, okay, let's say I have a number equals to 2 times 2 times 3 times 3 times 5 times 5. And they ask you, is this number a square number? The answer is yes. It is a square number. Because you have one pair of each numbers. You notice you have two twos, one pair. Two threes, one pair. Two fives, one pair. If you were to split them into two groups, you will have exactly two of the same group of numbers. Multiply them together. You will get a square number. But if I come up with another question, the question says that, okay, now is this a square number? I erase one of the number fives. How many of you think that this is no longer a square number? Raise up your hand. Yes, Wuyon raised up his hand. Yes, that's not a square number anymore because you have a missing number 5. Okay? If I were to split up these numbers into two groups, I can get 2 here, 2 here, 3 here, 3 here. But I only have one number 5. I do not have another number 5. So then the two groups, group A and group B, will be different. Cannot give you a square number anymore. All right? So remember, students, if you want to get a square number, make sure that every single number has a partner. It must come in a pair like this, and you must have an extra 5 here to form a pair. And if ever you have 3 numbers like this, students, do you think this will be a square number now? Who thinks yes? Raise up your hand. Anyone? Now I have 3 number 5s. Do you think it'll be a square number? Raise up your hand if you say yes. Ah, Talia, you raise up your hand. Do you think this is now a square number?
Yeah.
Okay, let's split them into two groups. Huh? Square number, you must have the same number multiplied by the same number. Yes or no, Talia?
Mm-hmm.
Okay, come, let's split them into two groups. I
Oh,
bring the...
no.
Ah, very good. So I bring the 2 here. I split up the 2s, I split up the 3s, and I split up the number 5s. Then I have one extra 5 there. So I put the 5 here. Uh-oh, are the two groups the same? No. This is not a square number, okay, students? All right, so I hope you understand what's a square number. We'll do more examples later on when we come across the word problems, yeah? So let's continue trying to break up the numbers into the prime factors. 2, 2, 0, split them up, 22 times 10. Then 22 can be split up into 2 times 11. 10 can be split up into 2 times 5. Circle all the prime numbers. And after that, we will write them down, arranging them from the smallest to the biggest. So 2 times 2 times 5 times 11. And it is done. All right? So any questions so far, students? Raise up your hand. Anyone? Yes, Maximus. Question.
And actually, you just use 2 squared times 5 times 11.
5 times 5 times 11. 5 times 5.
No, 2 squared times 5 times 11.
Oh, yes, you can do 2 squared times 5 times 11. Very good. No problem. Because 2 square means what? 2 times 2. Okay? 2 cube means what? 2 times 2 times
2 times 2.
Very good. Okay, so this is called the power. Yeah, you can do this also. Very good, Maximus. So students, I tell you what, why don't I give you all 2 minutes? Can you all do C, D, E, F right now? And when you're done, you just need to type in the chat group, done. Have you done, Benjamin, have you done part C? Can we do it together? 350. If I split it up, what do I get? What times what?
100 times 35.
Wait. 35 times 100. Okay, so what is 35 times 100?
3500.
Oops, too many zeros. So what should you do?
35 times 10.
Very good. Okay, then 35 is what times what?
7 times 5.
Very good. Then how about 10?
2 and 5.
Yes, so we circle all the prime numbers, okay? Now, after circling the prime numbers, we're going to write down 350 equals to...
5 times 7.
Arrange from the smallest to biggest.
2 times 5 times 5 times 7.
Very good. Well done. Let's try one more. 84. 84. What are you going to split it into?
Um,
Do you think it can be divided by 4 or 3? Can it be divided by 3? So how would you know if a number is divisible by 3, Benjamin? If I ask you, number 123, do you think this number can be divided by 3? Yes or no? All you need to do. Yes. What do you think? Can you tell?
no.
Okay. All you need to do, right, is you take the digits, all the digits, for example, 1, then you add up. You add all the digits together. 1 plus 2 plus 3, what do you get?
6.
Then you ask yourself, is 6 divisible by 3? Yes or no?
Yes.
Therefore, if the answer is yes, that means the bigger number is also divisible by 3. Understand?
Yes.
In fact, if I take 1, 2, 3, I divide by 3, right? The answer will be 41. All right? Sorry, let me write down the 3 here. Yeah. Okay, so 84. Do you think it is divisible by 3? You take the digits, you add them together. What do you get?
12.
Do you think this is divisible by 3?
Yes.
So, can 84 be divided by 3?
Yes.
Yes. Okay, so if we take 84 divided by 3, we'll get 28. So now do you think 28 can be divided by 3? Yes or no?
No.
Nah. 2 plus 8 is 10. Cannot. So 28 can be divided by 4?
No.
Yes, can. 4 times what is 28?
4 times 7.
Yes, correct. What about number 4? Can we split it up?
2.
2
Yeah.
times 2. So now we circle all the prime numbers. And I'm going to write down 84 equals to, tell me.
2 times 2 times 7.
Try again, try again. There's a
Times
reason why I circle all the prime numbers. So that we won't miss out.
8.
2 times what?
3.
Yes. Then?
7.
Very good. Well done, Benjamin. Any questions about this, Benjamin?
No.
Okay, well done. So students, this is C and D, okay? Now, let's try 78. Can I get Jun Chen? Jun Chen? 78. Split it up. What do we get? Divide by what first? You want to divide by 3?
2.
Can it be divisible by 3? Is it divisible by 3? What is 7 plus 8?
11
7.
plus 8 is 15.
So do you think 78 can be divided by 3?
Yes.
Yes, very good. But if you want to divide by 2, it's fine also. You can just divide by 2. So 2 times 39, no problem. What else? Do you think 39 can be divided by 3?
10.
Can. Okay, let's take 3 times what? 3 times what equals to 39?
12.
3 times 12 is 36.
13.
Yes, very good. Then 13. Okay, let's split up the 13. 13 equals to what times what? Can or not? Can split up or not?
No.
Cannot. Why? Because it is a prime number. Yes. So we circle all the prime numbers. And I'm going to write down 78 equals to,
2 times 3 times 13.
well done. Try the last one. 204. What are you going to do? Divide by 3 or divide by 2 or divide by 4? What do you want to do?
2.
Okay, divide by 2, 102. Next, what do you want to do? Divide by 2 again?
Yes.
Okay, then 2 times 51. Okay, then 51, what can you do?
No.
You think it can be divided by 3? What is 5 plus 1?
6.
So do you think it can be divided by 3?
Yes.
Yeah, so take 3 times 17 and that will give us 51. Now 17, let's split it up. Can we split it up?
No.
No, because it is?
Prime number.
Well done. So I circle all the prime numbers. And now I'm going to write down from smallest to biggest. 204 equals to?
2 times 2 times 3 times 17.
Well done. Thank you, Junchen. Good job. Okay. So students, this is how we do it. Anyone want to clarify anything about the factorization? So we have used branching. We circle all the prime numbers. Once you have circled all the prime numbers, you can write it down in a sentence, number sentence. And the number sentence, you arrange the numbers from the smallest to the biggest so that you will not make any careless mistakes, especially when you're doing word problems. Yeah? Let's look at example 2 now. They say that there are two prime numbers, and these two prime numbers add up to 40. Okay, so what they're trying to say is that, okay, let's say there are two prime numbers, A and B. When you add them up, you get 40. So it can be any two prime numbers, right? They didn't have any rules about, they don't have any other conditions. It can be any two prime numbers that can add up to 40. And then they're asking you to find the product. Find the product. So once you find what is A and B, they're asking you to find A times B, which is the product. So students, can you all try this question? First, you must do some experiment to find out what is A plus B. Make sure that A and B must be prime numbers. It must be prime numbers. Two prime numbers, you add up to 40. Then you multiply them together. What do you get? Can you type it in the chat? Looks like Talia got it already. Who else? Who else? Try your best. These are all the very basic prime numbers, okay? You all can try to test which prime numbers can add up to 40. Try to test which numbers can add up to 40. Ah, looks like Maximus got it as well. There can be more than one answer, students. If you want to give me more possible answers, you can do so. I will still accept your answer. As long as A plus B equals to 40, you are correct. So far, Talia and Maximus found it. You have 1 more minute, students. Looks like Kate also found it. Very good. Kate found a possible answer. Benjamin also found a possible answer. Very good. Talia found another possible answer. Very good. How about Wu Yon? How about Junchen? Wu Yon found it. Very good. Junchen also found it. Well done, students. Now, there can be various possible answers, okay? And I'm very happy that actually all of you, the combined answers from all of you, actually already found all the three possibilities. So one of the possibilities, we start from the smallest, okay? We just start from the smallest. A plus B equals to 40. Okay, let's just say A equals to 3, B equals to 37, and then you know that A plus B is 40, right? Okay, 37 is a prime number. So now they say what is A plus, what is the product? So A times B will be 111. So that is the very first possible answer. Next, we can also have A equals to 11 and B equals to 23 And then if you take A times B, right, you are going to get 319. So that is another possible answer. Finally, we can also have A equals to 17, B equals to 23. And when you multiply them together, you will get 391. Okay? Sorry, this 29. Sorry, 11 plus 29 is 40. 17 and 23 is 40. Now let me just double check. 11 times 29, 319. Correct. 17 times 23 is 391. Yes, correct. It's just the 19 and the 91 switch places. Okay, so all these are all possible answers. Okay? Good job, students. As long as you find any one of these, you are correct. And so far, I think everyone got it. So let's try the next one. Example 3. Now, again, you come across the same word. This word, product, it means multiply. So what they're trying to tell you is that there are 3 whole numbers. Oh, 3 whole numbers, like for example, A, B, and C. Okay, you multiply them together. They say the product of A, B, and C is 120, right? One of the numbers is the sum of the other 2 numbers. So now they're asking you to find all the 3 numbers. First thing we should do in this case, break it down. Okay, break it down so that you know all the factors. So now we are going to break down the number 120. One two zero equals to 2 times 2 times 2 times 3 times 5. Okay? So students, once we make a list of all the factors, then we already know that we have 3 numbers. But guess what? You have a total of 5 factors here, right? So what are you going to do? You will have to combine some of the numbers, combine some of the factors in order to find the number. So for example, we're just going to write down A equals to something, B equals to something, C equals to something. Let's say I combine this. Let's say A equals to 3 times 5. Okay, A equals to 15. Let's say I combine these 2 numbers. I say B equals to 2 times 2, 4. And then there's a one more remaining number here. I just say C equals to 2. Okay, so is this correct? Now you have to check. The question says that one of the numbers is the sum of the other 2 numbers. Do you see any number that is the sum of the other 2 numbers? I don't think so. So obviously the way that I've combined the numbers is wrong. So I tell you what, I'm going to give you 1 minute. Can you all try to go and play around with the numbers, combine them together, and such that you can have one number which is the sum of the other 2 numbers? Your time starts now. 1 minute.
The numbers. I first
Okay.
tried to go and times the same numbers together.
Okay, so you took 2 times 2 times 2 and you got 8.
Yeah.
Then what do you do?
Then I just left the rest.
3 is B, 5 is C, and you realize that these 2 numbers is A is the sum of B and C, right? Well done. That is absolutely correct. Thank you, Talia. You got it. So we found the 3 numbers, 8, 3, 5. Good job. So students, anyone have any questions about this? Okay, so there's so many ways that you can combine the numbers. Okay, you can even take 2 times 3 equals to 6. Okay, and then 2 times 2 is 4. And then you have one more number, 5. But you still cannot have 2 numbers adding up to another number. Okay, so these are all wrong. So the best way to do it, and actually the only way to do it, is 2 times 2 times 2. You combine them, you get 8. Then you have 3 and 5. All right, let's try the next one. Practice example number 4. Now you're talking about square numbers. I hope you remember what I told you. So the product of A and 60 is a square number. Find the smallest possible value of A. So again, let's try to split number 60. And we find out that 60 equals to 2 times 2 times 3 times 5. And in order to have square numbers, what must we do? We must take two numbers which are exactly the same and multiply them together. So if I were to try to move the numbers into each group, okay, this goes here, no problem, they are the same. And then I have a 3 and I have a 5. Okay, let's say I move the 3 and the 5 here. Now let me ask Kate. Kate, are these two groups the same?
No.
What do I need in the other group?
3 and 5.
I need a 3 and I need a 5. And where do you think I can get an extra 3 and 5 from the number 60? No, because the number 60 only has 1 3 and 1 5, right? Where do you think the other 3 and the other 5 is going to come from? They said that the product, what is the meaning of product?
Times.
Yes, that means what are they doing? They are taking A times 60, right? Where do you think I can get the 3 and 5 from? I can get it from the number A. Okay?
Oh.
Yes, I can get it from the number A, okay? So what I'm going to do is this. We need a 3 and we need a 5. So therefore, the value of A must be, it must consist of a 3 and it must consist of a 5. So A equals to?
15.
Yes. So when you multiply them together, okay, when you multiply A and 60, what are we actually doing? We are taking A, this is A, multiplying it by 60. 60 is like that. This is 60, right? Now you realize that there's two twos, there are two threes, and there are two fives, and now it becomes a square number. Understand, Kate? Because we are multiplying them all together. Now, can A be equal to, for example, 3 times 5 times 10? So then A equals to 150. Do you think this is also possible? Sorry, times 3 times 5 times 2 times 2. So let's say 3 times 5
Yes.
is 60. Do you think A can also be 60? Actually, yes. Okay, yes. As long that every number has a partner. Can you see every number has a partner? Partnering. And this is also a partner. It will still become a square number, Kate. Right? But in this case, the answer is wrong. It cannot be 60. Do you know why?
The smallest.
Yes, because they want you to find the smallest value of A. So we should not multiply it by anything else. We just get the bare minimum that we need. Okay, we just get the bare minimum that we need, which is only 15, and that's all we need to make it a square number. Okay?
Okay.
All right, well done, Kate. Anyone has any questions? Raise your hand, students. Okay, anyway, just remember that I'm going to send you the solutions after class. Please don't be busy copying. I would like you to ask questions during class, okay? Now, moving on. Okay, let's take a look at that. Consecutive zeros. So, how do we find consecutive zeros? Whenever you see a 2 and a 5, you will be getting a 0, which is here. Okay, so if you see two 2s and two 5s, okay, this is 10 times 10, 10 times 10, you will have two zeros. Two 2s and two 5s gives you two zeros. Three 2s and three 5s gives you three zeros, right? Okay, so whenever you have a pair of 2 and 5, you will get a 0. Now, this question is telling you that there are 6 zeros, 6 consecutive zeros. So now what we must do is we must count how many 2s and how many 5s we have. So let's split up the numbers. 172. Gonna split it up. Let's say I divide it by 2, I'm going to get 86. Split it up, 43. Split it up. Can I continue to split this up? Is 43 a prime number, students? Who thinks I can split it up? Hey, sorry, why am I doing 172? It's 175. Okay, 175. Split it up 5 times 35. Then I have 5 times 7. Done. So I already know that 175 equals to 5 times 5 times 7. Next, I will split up 72. I think I was confused with the 175 and 72. It became 172. So I divide by 2, 36. I divide by 2 again, I get 18. I divide by 2 again, I get 2 and 9. I divide by, 9 is equal to 3 times 3. So there you go, like that. Circle all the prime numbers. And we write down 72 equals 2 times 2 times 2 times 3 times 3. Now let's move on to the next one, which is 225. So if I split this up, I'm going to divide it by 5. 5 times 45 is 225. 5 times 9 is 45. 3 times 3 is 9. So now I've split everything up. And I'm going to write this down. 225 equals to 3 times 3 times 5 times 5. Let me ask Maximus. Maximus, over here, how many 2's do I have altogether?
2 cube. You can just do 2 cube.
Correct, I have 3 2's. What about 5's? How many 5's do I have
2
altogether?
5, so you can just do 5 square.
Nope, I have 4 5's.
Oh, 4 5, where? Oh, bruh. So it's
Yeah.
5 to the power of 4.
Yes, correct. So far I have 3 2's and so far I have 4 5's. In order to have 6 zeros, Maximus, how many 2's and how many 5's will I need?
5. Yeah, 5.
How many 2's and how many 5's in total do I need to get 6 zeros? Yes, I need 6 2's and I need 6 5's, but I only have 3 2's. Can you tell me how many more 2's do I need?
3.
Yes, I need 3 more 2's. Where do you think the extra 2's are going to come from? I already split.
235.
No, I already split up. I already split up 175. I already split up 72. I already split up 225. These 3 numbers only gave me 3 2's and 4 5's. Not enough. There's one more number. What is the last number? What is the last number?
B.
B, correct. The extra 2's and the extra 5 is going to come from the last number, which is B. So I will be needing 3 more 2's. And how many more 5's will I be needing? 2. Yes, I will be needing 2 more 5's. Okay, because now I only have 3 2's, but I need 6.
Yes.
So I need 3 more 2's. And in order to get 6 5's, I will need 2 more 5's. Okay? So can you help me to calculate this? What will I end up with?
4 for 10 to 8. 200.
Well done, Maximus. So the B will be equals to 200. Can my B equals to for example like that, something like that? Yes or no? Or maybe let me add an extra 5. Yes or no? Is it possible? It will still give me the extra 2's that I need. Or maybe let me write down 7. Okay, can I just multiply it? Can I just write down an extra 7 like that, Maximus?
Huh?
Can I just write down an extra 7 here for the B? Because no matter what, it is still giving me the 2 and it is still giving me the 5's that I need. But what if I just add an extra 7. There's no harm, right? You just add more. Because I only need 3 more 2s and 2 more 5s. It already gave me this. I'm very happy. I have enough 2s and I have enough 5s. It doesn't harm if they give me another 7, right?
No.
Does it harm?
Yes.
It harms? Really? It harms?
No,
Yes.
no, it doesn't.
Well, it does.
Yeah, I just said.
Why does it harm? The question wants the smallest possible value of B.
Yeah.
Right? Okay, so you can only give the smallest value. You should not be giving any more than that. All right?
Yes, sir. Yes, sir.
Okay. Thank you, Maximus. Students, any of you don't understand? Any questions? Raise your hand, students. So you just count how many 2s and how many 5s you have, right? And then how many more do you need? It comes from the B. And B must be the smallest possible value. So don't just add any extra factors that you want. Keep it to the minimum, the bare minimum that you need. That is the smallest possible value of B. Okay? Moving on. Oh, Benjamin. Oh, you told your friends, Benjamin. Okay. So what is Benjamin telling his friends? The product. Okay, that means he's multiplying. What is he multiplying? He's multiplying his exam score, his age, and his ranking. Okay? So Benjamin multiplied his score, his age, and his ranking, and what happened? He got 4,074. So why not we split up 4,074? Divide by 2, divide by 3, and this one can be divided by 7. This is all prime number. 97. 97 is already a prime number. You can't divide it any further, okay? So these are the factors, prime factors. So we can say 4074 equals to 2 times 3 times 7. Never mind, let me just make more space. 4074, 2 times 3 times 7 times 97. Now, you have 3 things that you have multiplied, right? You multiplied the exam score. Okay, let's start with the age. You multiply the age, you multiply the exam score, and also your ranking. These 3 things multiplied together to give you 4074. So again, what must we do? We must try to combine the numbers. Maybe you can combine this and you can say that my age is 6 years old. My score is 7. My rank is 97. Or maybe you can combine, or maybe you don't want to combine. You straight away take this and say my age is 97 years old. Right? And then you combine this and say that my score is 21 and my rank is 2. It's up to you, students. I tell you what, I'll give you 30 seconds. Can you tell me what is your age, what is your exam score, and what is your rank? Okay, Benjamin, come, let's do this together. So Benjamin, we have 4 numbers here. We want to combine them to get 3 numbers, okay? So what do you think is the exam score? I think the easiest one. Let's start with the exam score. What's your exam score? What's the most obvious? Benjamin is a very smart guy. What's his exam score out of 100? Choose any of these numbers. Come on.
3.
Sorry, say again.
7 times 3.
Wait, sorry, again.
7 times 2.
21. Why don't you just choose 97? It's like, isn't that the best score? Okay, let's choose 97. Okay. Now, if his exam score is 97, what do you think is his rank and his age? Sorry?
Maybe
You already use up this number, so you have 3 more numbers left. So you want to combine which numbers to get the age?
2 times 7.
Okay, 2 times 7. And then we have 14 years old. Okay, that means he's in secondary school. Very good. And what is the last remaining number that we have not used?
3.
Yes, his rank is 3. Well done, Benjamin. That is very believable, okay? Because he scored 97 out of 100, he is the top 3 in class. Yeah, that's very believable. Maybe somebody else got full marks, 100 marks, and then another person got 99 marks, and then this guy got 97. So maybe he's a third in class. Believable or not, Benjamin? Can?
Yeah.
All right. You have any questions about this, Benjamin?
No.
No? All right. So students, this is actually the most believable answer. Now, obviously, the question did not state any rules. The question did not say that his age must be younger than 21, or the question did not say that his rank is smaller than 5 or anything like that. So really, anything goes. Even if you say that his age is 97 years old, his score is 3 out of 100, and his rank is number 14, it is also possible because the question did not say anything. All right, but maybe when you do other questions in the exam, maybe they will say that his age must be a certain age group. Then you have to follow the rules of the question. Okay, so let's try practice number 1. I will give you 2 minutes, students. Try your best to write down all the factors. Use the branching method. Okay, so the branching method like this. Okay, you start to split up all the numbers, right? Then you write down all the factors of each number. I'll give you 2 minutes. Your time starts now. So for 97 is already prime, so we don't have to split it up. For 207, we split it up. We circle all the prime numbers. We get 207 equals to 3337. Okay, Talia, try one more. 187.
187 is 11 and 17.
Very good. And these are already prime. So we can immediately write down 11 times 17. Thank you, Talia. Well done. So let me ask Wuyon. Wuyon, let's try 240. 240. What are you going to split it into?
240.
Let's split it. Split it up.
240.
Oh, I'm sorry. You're supposed to multiply, okay? 200 times. Yeah. So what are you going to do?
24 times 10.
Yes, excellent. And then?
24 is
3 times.
8.
Very good. 8 equals to
4
okay.
times.
I know we can do 4 times 2, but I'm gonna save some
2
time.
times 2 times 2.
Good job. 2. We can do this. Okay, you don't always have to do 2 branches. You can even do 3 branches. Now what about
4 branches? 5, 6,
yeah,
7, 8.
yeah, you can do if you have 16, then you can do 4 branches. 2. Okay? Yeah. What about 10?
10, 5, and 2.
Good job. So now we're going to circle everything, all the prime numbers. And then we're going to say that 240 equals to
3 times 2 times 5 times 2 times 2 times 2.
smallest to biggest. And can you use power? I want you to use power. For example, 2 to the power of 2 equals to 2 times 2.
Oh, okay.
Okay.
2 to the power of 3. I mean 2 to the power
No.
of 4. 4.
Yes, correct.
Then
Times.
3 to the power, no, it's 3, right? So 3
Yes.
times 3 times 5, I mean.
Very good. So there's no need for the power for 3 and 5, right?
Mm-hmm.
Good job, Uyon.
But if
Okay,
you want the power, then just 3 times 1.
no, you must say power. You must say power
Yes.
of 1.
3 to
Yeah.
the power of 1. But just 2 is
Yeah.
3.
But you don't need to lah, huh? Wasting. Okay, it's just a waste of time. Oh, wait, hold on. Kate put up her hand. Hold on. Yes, Kate, question.
I thought for question B was 3 times 3 times 23.
Oh. Oh, yeah. Talia, I think there was a mistake here. Thank you, Kate. Actually, you know what? 69 divided by 3 is
23 is a
20.
prime.
Well done. Thank you, Kate. Okay, so it's actually 3 times 3 times 23. Well done, Kate. Thanks for informing us. So let's continue with Wuyon. Let's try another one, shall we? 330. 330. Split it up. What do we get?
33 and 10.
Yes. And then?
33 is 11 times 3.
Yes. And these are already prime numbers. Then 10?
2 and 5.
Good job. So now we're going to arrange it from smallest to biggest. 330 equals?
2 times 3 times 5 times 11.
Well done. Okay, thank you, Wuyon. Good job. Good job. Now let me ask Kate, can you try the last one? 300.
300 equals 3 times 100. 100 equals 5 times 20. 20 equals 5 times 4.
That was fast, eh? 20 equals to 5 times 4. And that's all, right? We circle all the numbers. Is that correct? Oh, are you sure?
No. 300 equals 3 times 4 times 5 times 5.
Is this a prime number?
No. 4
Ah.
equals 2 times 2.
Very good. So now we are going to circle all the prime numbers. And what do we get, Kate?
300 equals 2 times 3 times 5 times 5.
Well done. All right. Thank you, Kate. Good job. Huh? So, students, this is how we factorize. Okay. Now, let's take a look at question 2. Now, they say that there are two prime numbers that add up to 28. Find their product. Isn't it the same as one of the examples we did just now? There are two prime numbers. They add up to 28. The question is asking you to find the product. So please, students, take 1 minute. Can you find the answer? Oh, Talia, that was fast. Oh, Talia found two possible answers, eh? Maximus got it as well. If you can find different possible answers, please go ahead. Just give all the possibilities that you have found. Looks like Wuyon found something as well. Good. Yes, Benjamin.
Can I go to the toilet?
Go ahead. "30 seconds left. What about the rest of you? Have you found anything? Wuyon. No, Wuyon, no. 19 plus 7 is 26, not 28. Try again. All right, let me ask Jun Chen. Okay, Jun Chen, let's take a look here, right? Oops. Yeah. Okay, so Jun Chen, let's start from the smallest prime numbers, okay? Can you just tell me some small prime numbers Let's start from 2. After 2, it is
2, 3, 5, 7, 11.
very good. So let's take a look at 3. Can I take 3 and 25?
No.
No,
is
because
not prime.
yes, 25 not prime. Very good. Then we continue. After 3 is what? Prime number.
5.
5. 5 plus 23. Are these both prime numbers? Twenty-three is prime number. Okay. So can we have this answer?
Yes.
Yes, very good. Can we try to find other possible answers? Okay. After 5, what is the next prime number after 5?
7.
So I will take 7 plus 21 equals to 28. Can or cannot?
Cannot. 21.
Cannot. Yeah. Then after 7 is
11.
11 plus 17. Can? 17 prime number?
Yes.
Very good. Okay, so we have these possibilities. Now, after 11, there's of course 13. Okay, the next prime number is 13. So you have 13 plus 15, but 15 is not a prime number. Okay, then after 13, the next prime number is 17. But we already found 17 and 11. So I think from here on, there are no more possible answers. Okay, so let's take the question is asked, is this the final answer or not? Jun Chen.
This
What do
is
they
find the product.
product? So we must take A times B, okay? So for this, we get 115. And for this, A times B, we will get 187. And so we have two possible answers. Thank you, Jun Chen. Good job. Jun Chen, you have any questions?
No.
No? All right. Okay then, students. Since there are no questions, we will move on to the next one. Let's take a look at question 3. The product of two consecutive whole numbers is 756. Find the two whole numbers. Okay, so consecutive numbers. Okay, let me ask Maximus, what is the meaning of consecutive?
One after another.
Yes, one after another. So let me write down some numbers. Are these consecutive numbers?
Hmm?
Look at my screen. Are these consecutive numbers?
Mm.
What about this?
No.
Why not?
Yeah. Yeah. No.
Yes or no?
No.
Why not?
Because it's 1, 2, 3, 5, 6, 7. There's
So what?
supposed to be another 4.
Yes, there's a missing number 4. Okay, so it's not consecutive. Very good. So now there are two consecutive whole numbers. So maybe if I have two numbers, like for example, 5 and 6. Okay, they say the product. Again, let's highlight the word product. That means you multiply. Two numbers, you multiply them together, you are supposed to get 756. Do you think this is the answer?
No. Because
Okay, now,
that's the only.
of course, if you can, of course, if, we can guess, we can keep on guessing the whole day, right? We can keep on guessing and guessing and guessing.
But that
But
does not work.
yeah, you might or might not find the answer. And even if you find the answer, maybe it will take a very long time. So what should we do, Maximus? What do you think?
What?
What should I do to this number 756 first?
Squaring.
Sorry?
What? Square root.
Square. No, okay, we will use the same technique that we have always been using this whole lesson.
Branching.
Branching. Okay, so I divide it by 3, we get 252. We split it up. Okay, we divide it by 3, we get 84. We try to split it up again, divide by 3, we get 28. We split it up again, 28. 2 times 14. And 14 equals to 2 times 7. So we circle all the prime numbers. Now, Maximus, tell me, what am I going to write down? 756 equals to?
3 times, no, 3 cube times 2 square times 7.
You're technically correct, but arrange them from smallest to biggest.
2 square times 3 cube times 7.
Very good. Now, Maximus, I know you love powers. I know you love powers, but in this case, it will really help if we write them out like that. And I'm going to show you why in just a moment, okay? Now, why am I not taking the shortcut? Okay, this is a shortcut, very nice, it works. Why am I writing it all out? Because I need to combine the numbers into two whole numbers. Okay, Maximus? Now let's try to combine some numbers. Okay, imagine you have two numbers, whole numbers. One is A. Okay, one whole number is A, and another whole number is B. Okay, why not you try to combine? Okay, let's just try. Okay, let's just try to combine maybe this. So what do we get if I combine these three? 2 times 2 times 3, what do I get?
12.
12, okay. Then I combine this, what do I get? 3 times 3 is 9. 9 times 7 is?
63.
Are these two consecutive whole numbers, A and B?
No.
So what's the point here? The point is the question. The point of the question is that you must get two numbers which are consecutive whole numbers. I know that Talia already found it. Very good, Talia. So Maximus, how about you? You want to take a look? Okay, which numbers you want to combine? Let's try. Okay, let's try. Tell me which numbers you would like to combine. Oh, Maximus found it already. Okay, Maximus, tell me which numbers did you combine to find it?
3 times 3 times 3.
Very good.
3
Three
cube.
times 3 cube, and you got 27. Then
3
what
times 3
is...
times 3.
Yes, so what is left behind? Okay, so let me write down 3 times 3 times 3 first. And you get 27. And what is left behind? 2 times...
2 times 2 times 7. 2 square times 7.
Very good. So are these two numbers consecutive? Yes, they are consecutive. Okay? They are two consecutive numbers. You got the answer. Well done. Good job, Maximus. So students, you see, whenever we are faced with a very big number, instead of spending a lot of time doing guess and check, we break down the number and then we ask ourselves, what do we want to combine? Okay, then you do your combinations and finally you will come across the answer. Any questions, students? So once you do your combinations, all you need to do is follow the rules of the question. Question says it must be two consecutive whole numbers. And we have already checked. These two are whole numbers and they are consecutive. 27 followed by 28. Then the answer is correct. Moving on to question 4. Now, in question 4, there are 3 people, right? There is Mark, there is Nick, and there is Pearly. Again, they are talking about product. That means you multiplied all the ages together. You multiplied all their ages together. So for example, what happened in the question? You took Mark's age, multiplied by Nick's age, multiplied by Pearly's age, and you got 360 here. Right? So what must we do? Again, we will do the same thing. We will split up the 360, just like what we did here. Split up, get all the prime factors, and then you start to combine them together. Your purpose is to find Mark's age, Nick's age, and Pearly's age. Can I give you 2 minutes, students? Please try this question now. Okay, let me ask Kate. So Kate, have you split up number 360?
360 can go to 3 and 120.
Okay, 3 and 120. Then
120 goes to 3 and 40. 40 can go to 2 and 20.
what else?
20 goes to 2 and 10. And
Okay,
10 goes to 2 and 5.
oh, okay, fair enough. So we'll get all the prime factors here. And we'll write down 360 equals. What will we write, Kate?
360 equals 2 times 2 times 2 times 3 times 3 times 5.
Good.
Equals 2 to the power of 3, 3 to the power of 2 times 5.
Yes, you're absolutely correct. But in this case, I'm not going to do that because why do you think I'm not going to do that? Because I want to combine the numbers. I need to find the ages of Mark, Nick, and Pearly. Am I right, Kate? So why don't you just combine two numbers and tell me what Mark's age is? Just choose any two random numbers.
Mark's age could be 2 and 5 makes 10.
Okay, let's just try 2 and 5. And what do you think?
Oh, no,
Nick?
no.
Why not? Oh, no, it's okay. Just continue. Let's just try the experiment.
Oh, then 3 times 3 is 9.
3 times 3 is 9 for Nick. Okay. So Nick is 3 times 3, which gives us 9. So far, are we following the rules of the question?
Yes.
Because Mark is 1 year older than Nick.
Then
Very good.
2 times 2 is 4.
2 times 2 is 4, and that will be Pearly. So are we following the rules of the question?
Yes.
Because Nick is actually 5 years older than Pearly. Well done. You see? You got it on your first try, Kate. Good job. Any questions about this? How do you find it? Was it easy? Kate? All right. So students, any of you have any questions about this? It's the same method that we used for question 3, okay? Split the numbers up. Okay, I know you can write powers, but if you write it in terms of powers, sometimes you can't really combine the numbers together, okay? It's more difficult. If you write it out like that, at least you can see what numbers you are combining and what numbers you are left with. So just do your experiment, try to combine everything, write it down, check whether it follows the rules of the question. There are 2 rules in this question, am I right? If it follows the rules of the question, you got it. Okay? Moving on. Question 5. The product of M and 2376 is a square number. So remember, students, if you want to get a square number, you need 2 numbers exactly the same multiplied together in order to give you a square number. So what are we going to do? We're going to split 2376. Let's see how many pairs of numbers we can get from this. So let's start with 3 times 792. And let's continue to split it. 3264. Let's continue to split it. You get 3 times 88. Continue to split it. And you can get 8 times 11. And remember this trick. 8 equals to 222. 2 times 2 times 2. Circle everything. Then you can write down 2376 equals to 2 to the power of 3 times 3 to the power of 3 times 11. So, Junchen, you have a question?
Isn't it supposed to be 4 times 2, but there's only 3 2s?
Let me show you. 8 split up 4 times 2, split up 2 times 2, 2 times 2 times 2. Can you see this?
Oh.
So I'm just skipping the 4. Because I already know that 8 equals to 2 times 2 times 2, right, Junchen? So let me ask you this, Junchen, okay? If I would like to have a square number, I need to have 2 groups of numbers which are exactly the same. How many 2's do I have, Junchen?
3.
3. So let's put one 2 here. Let's put another 2 here. And let's put another 2 here. There are 3 2s, right? Okay, how many 3s do I have?
3.
3. Let me put a 1 3 over here and 1 3 over here. And another 3 over here. And how many 11s do I have? I only have 1 11, right? Junchen, when you look at it like that, are the two groups the same?
No.
What is missing from group B?
11. 1 11.
Yes.
1 2 1 3.
1 2 and 1 3. Yes, correct. Where do you think the missing numbers can come from? Where do you think we can get the missing numbers from? We can get it from M, right? So what do you think M should be? Okay, we are missing. Okay, look at M. Okay, so now anything that is missing must come from M. How many 2s are missing again?
1
You
2
have 1 2. And how many 3s?
1 3.
And how many 11s?
1 11.
Good. Can you tell me what is M? Multiply it together. Tell me what is M.
66.
66. Good job, Junsen. Well done. Junsen, you have any questions about this?
No.
All right. Looks like Talia and Maximus also gave me the answer in the chat. You are correct. Well done, students. So this is how we do it. Okay. Now let's take a look at our final question. Oh, wow. Something special that some of you might not have seen before. There's a line over here. Okay, don't be alarmed. Okay, let me explain what that line is for. So in algebra, okay, students, in algebra, right? In algebra, we actually use alphabets to represent numbers. For example, X and Y. I think some of you may have heard of this before. So if you have X, if you write down a number X, Y, what does it mean? When you write two alphabets side by side, it actually means multiply. It means multiply, X times Y. If you write two alphabets side by side, A and B, it means A times B. Understand? So what is the difference? Okay, so let's say students, let's say I have this alphabet A equals to 1, B equals to 2, C equals to 3. If I'm going to write ABC like this, what does it mean? It means A times B times C. That means 1 times 2 times 3, I will get 6. What is the difference if I draw a line? If I draw a line, it means that ABC is a 3-digit number. That means just 1, 2, 3, 123. That's all. It simply means do not multiply them together. It is a 3-digit number, 123. Okay, students? So when you see a line on top, it means that this is a 5-digit number. That's all. And the question even told you that, yeah. So it's A8388. The question already told you that the three digits in the middle is 838, okay? So when you see a line, it is just a 5-digit number. So 4 consecutive even numbers. Can I ask Talia, what is the meaning of consecutive even numbers? Can you give me an example?
2 4 6 8.
2. Okay, hold on. 2, 4, 6, 8, 10, 12, blah, 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 blah. These are all consecutive even numbers, right?
Yeah.
Give me examples of consecutive odd numbers.
1, 3, 5, 7, 9,
Very good.
11, 13.
11, 13. Yes, correct. So what the question is saying is that if you multiply, okay, the product means multiply. The product of 4 consecutive even numbers is going to give you a 5-digit number, A838A. Okay, so for example, if I take these 4 consecutive even numbers, I multiply them together, I'm only going to get 384. Do you think it is big enough to give me a 5-digit number like that?
No.
Nah. Okay, so obviously we need to select bigger numbers. Okay, Talia? All right. So students, I tell you what, I'm going to give you 2 minutes. Can you all think of 4 consecutive even numbers that will be able to give you that 5-digit number which looks something like this? Okay? Okay, students. Wooyon, can I ask you, have you found anything?
I only found that I'm not sure whether it's correct, but I found out that A equals to 4. That both A equals to
Very
4.
good. How did you know, Maximus, you are correct. Talia, you are correct. How do you know, Wooyon? How do you know A equals to 4?
Because since A is a L is a letter, then maybe it's equals to a number. So 4 times 2 times 4 times 6 times equals to 384. So I saw a pattern that 388 equals to 384.
Very good. Actually, this, yeah,
And then the 883 equals to the back row of 384 equals to 483.
very good. This is a pattern. Excellent. Okay, students, actually, you see, this pattern here, right, is corresponding to this pattern over here. Oops, sorry, hold on. What's wrong with my pen? Okay, let me take it out again. It corresponds to the pattern here. So it's very good. It's very good that you have spotted this pattern here. Because if we were to try any other combination of, consecutive even numbers, for example, okay, 4, 6, 8, 10. 4, 6, 8, 10. You will not see any 3s and you will not see any 8s. Or even if you try 6, 8, 10, 12, you will not see 3s and 8s. The only time we see 3s and 8s is when we do 2, 4, 6, 8. Now, the only problem with 2, 4, 6, 8 is it is too small, correct?
Yeah.
So what can we do to make it bigger? What do you think?
10.
Very good. What if we tried 12? Wait, what's wrong with my pen? 12? Oh, you. Oh, I think I know what's wrong. 12, 14, 16, and 18. What will we get? Okay, let's go. 12,
It's just 3. Is it just 3 for A plus a 1 in front?
4, 8, 3, 8, 4.
Oh, just plus 1 in
Yeah.
front.
You cannot just add 1 in front. No, seriously, you want to try? For example, you take 2 times 4, you get 8, right? Does
Yes.
it mean 12 times 14 equals to 18? You just add a 1 in
No.
front. You can't
No.
you can't do that. Okay, so you get 4, 8, 3, 8, 4. Well done. And you realize that A equals to 4. Good job. So what are the 4
What do you mean
numbers?
you just add a 1 in the front?
Yes, I actually added a 1 in front of each.
Why do you add 1? Why not add 2?
Yes, you can, but it will be too big. Okay, you can add 2, no
Why do you
problem.
choose 1? Why do you choose 1?
You can do 2 to 22 times 24, 26, 28. You will still get 384, 384, but that's already a 6-digit number, correct?
And this is only a 5-digit. But why do you choose one, not other numbers?
I'm just going according to the order, you know, from nothing in front, and I'm going to try 1. But if 1 is too small, then maybe I'll add a 2 in front. So maybe if this is too small, then maybe I'll try this, right? Okay. So I'm just trying. We are not sure. Nobody can predict what the answer will be, but we have to try it first in order to get the answer, right?
Yep.
So now I've already tried it, and it happens that it fits into my pattern, 5 digits, 48384. I managed to get the answer. Well done, Wuyon. Okay, so this is how we solve it, students. We can look for the pattern and we can try. We can guess and check. So now we have found that the 4 numbers are 12, 14, 16, and 18. We even found that A equals to 4. All right, students, any questions about this? Raise your hands. No? Okay, so what did we learn today? Prime factorization. This is prime factorization. We have done it so many times by now. And we also learn square numbers. Whenever you want to find a square number, make sure that you have a pair of numbers. There must be the same numbers multiplied by each other to give you a square number. Okay, students? And one of the yes, Wuyon, question.
There's also another good way to remember a square number. So if you draw a square, then both sides are equal. So if there's two same of number, then it's already a square number.
Very good. So if you draw a square, the sides are the same. 5 times 5,
So just
25.
5 times 5, 25.
Very good. This is why they call it square numbers actually.
Because
This is the
both of the squares are the same.
yeah, because it gives you the area of a square. It gives you the area of a square.
Do you mean 5 times 5 times 5 times 5 is also a square number? 4 times 5.
If you take 5 times 5 times 5,
Is that a square number? Because there's two pairs of the number.
if you say 5 times 5 times 5,
5
this
times
is
5.
already a cube.
No, 5. No, the square, right? Then all the sides times together.
No, because you
Is
don't need to do that to find the area of a square. In order to find the area of a square, you just need to take the
Yeah.
side times the side.
You
Yeah.
don't have to take 5 times 5 times 5 times 5.
Nah, in fact, if you do that, it doesn't give you anything.
Yes.
Okay, so we learn about square numbers, we learn about factorization, and we also learn that when you do the problem sums, it always helps when you split up the numbers like that. And then you ask yourself, how do I combine the numbers together in order to follow the rules of the question? Then you can check whether your answer is correct. Okay, students? So what I'm going to do is I'm going to be sending you all the solutions as well as the recording of this lesson. So I'm going to email it to your parents. You can click on the link to do your revision and watch the lesson recording. Okay, students? Well done today. Please do your revision and I'll see you all next week. Bye, everybody. Bye, Wuyon, Benjamin, Junchen, Kate, Maximus, Talia. Bye.